All right, folks, welcome back to the channel. Today we're diving into something that's going to make your dev life a whole lot easier, working with the SelfNeuron product using its official Python SDK. Now, before we write a single line of code, let's talk about why SDKs matter. If you've ever spent hours crafting API requests by hand, you know the pain. A Python SDK takes all that boilerplate and abstracts it away. Think of it as your personal assistant for interacting with complex systems. With the SelfNeuron SDK, you get simplified integration, plug in and go, no need to mess with raw HTTP calls. Accelerated development, because who wants to reinvent the wheel? You get pre-built tools and helpers that shave hours off your build time. Abstracted complexity, say goodbye to managing auth tokens and error formatting manually. Improved usability, great docs mean less Googling and more building. Wider adoption, the smoother the SDK, the easier it is for others to integrate and build on top of it. And here's the exciting part. In this walkthrough, I'll show you how to use the SelfNeuron SDK end-to-end, from setting up authentication to making API calls to catching and handling responses like a pro. So let's jump in. All right, let's get this SDK up and running. The SelfNeuron Python SDK is available directly on PyPI, so installation is super smooth. Just run pip install SelfNeuron. That's it. No weird setup, no extra steps. Pro tip, use a virtual environment, Venv or Conda, to keep your workspace clean. And here's the best part. Installing via pip pulls in all dependencies. No config files, no dependency hell. You're ready to go out of the box. Now that it's installed, let's bring it into our project. From SelfNeuron import SelfNeuron as SNN, and just like that, you're officially ready to interact with SelfNeuron like a pro. Let's set up authentication with the SelfNeuron SDK so we can start making secure API calls. Here's what you'll need. base_RL. This is the endpoint where the SelfNeuron API lives, and your PI key, which you can generate from the API key section of the SelfNeuron dashboard. The base O is https://api.selfneuron.ai. And for the API key, I will head over to the SelfNeuron dashboard, where I can find the API section. In here, you can create your own API key by clicking on the Generate API Key button. Once API is created, you can copy the API key and head over to the code and assign it to the API key global variable. You'll also see a small snippet that lets you upload files directly in a Colab notebook. It even prints the file path and byte size. Once the file is uploaded, assign the file path and file name with extension to the appropriate global variable for future use. I am also creating global variables that hold relevant keywords that we will use while uploading and updating the imported document to the SNN account in the later part of this notebook. Now here's the important part. Once we have the credentials, we create an instance of the SDK. In this notebook, we create an instance and name it NN, and that's it. This N, or more specifically the SNN object, is now your gateway to everything SelfNeuron. Every function call from here on out, whether it's uploading, querying, or processing, is securely linked to your API instance through this object. All right, authentication's done. Let's move on to the fun part, making real API calls. 1. Authentication and account management. This set of APIs handles user identity verification and account-level actions. They're the foundation for building secure onboarding or login systems. 2. API key management. These functions help manage developer access to the system via API keys, great for apps that expose programmatic interfaces or have multiple environments. 3. User profile and subscription. This category gives you insight into user data, billing information, and subscription status, ideal for SaaS products or admin interfaces. 4. Artifact management. These APIs are all about uploading, organizing, and maintaining documents or files called artifacts in the SelfNeuron ecosystem. 5. Search and recommendation. These functions tap into SelfNeuron's intelligence layer, allowing you to build advanced search and discovery experiences. 6. Search history management. These APIs help you log, retrieve, or update search activity, ideal for building audit trails or personalized UX. Each of these functions works through the SNN object we set up earlier, meaning they're all tied to your authenticated session. In the next section, we'll use these methods with real data and walk through complete code examples. Now let's see how to actually bring content into the SelfNeuron system using the upload artifact function. This is the entry point for uploading any document or file. Think of it as adding content to your searchable, intelligent workspace. To do this right, you'll want to follow a few key steps. First, choose a supported file format. SelfNeuron currently supports .txt, .csv, and .json. That keeps things compatible with their back-end processing. Next, pick a meaningful keyword. This will tag your file and make it easier to retrieve later. It acts like a unique identifier for search and organization. Then pass the file and the keyword to the upload artifact function. That uploads the file to the server and links it to the tag you've specified. And finally, always confirm the upload succeeded, either through logs or by fetching the artifact list. This ensures the file was properly processed and tagged. Here's what that looks like in practice. In this example, we're uploading a file called mysalesreport.txt and tagging it with the keyword sales. Now, anytime we want to search or filter based on that file, the keyword makes it easy. A few quick tips to keep in mind: watch the file size. Make sure it doesn't exceed system limits. Stick to supported formats to avoid errors, and use unique keywords to prevent accidental conflicts when querying later. Once your file is uploaded, tagged, and the status of the search ready call in the dashboard turns yes, you can use SelfNeuron search and recommendation features to start extracting value from your content. Let's continue and see what we can do next with the uploaded artifacts. Now let's retrieve the keywords linked to our current session using getKeywords function. This function returns a list of keywords that SelfNeuron considers relevant based on the context, usually after you've uploaded or interacted with artifacts. You don't need to pass any parameters here. It works off the current state, so make sure your session includes some uploaded content. Here's how we use it. This will print out a list of contextual keywords tied to your artifacts. It's really useful for tagging, content analysis, or powering recommendation engines. Let's run it and take a look at what SelfNeuron has extracted. We can see the latest keyword sales that we used to tag the uploaded document, mysalesreport.txt, along with the other existing keywords in the account. Next, let's look at how to retrieve all the files you've uploaded using the getArtifacts function. This method fetches a dictionary of all artifacts currently stored under your session. Each entry maps a document ID to its file name, making it super useful for tracking and displaying uploaded content. Here's a basic usage example. This prints out the ID and name of every file you've uploaded. Whether you're managing research files, PDFs, or structured data sets, this gives you full visibility into what's in your workspace. You can also do a quick one-liner like this. A few quick notes. 1. Quality spotsable. You'll only see artifacts that belong to your session or access scope. If nothing's been uploaded yet, it'll return an empty dictionary. The return format is perfect for building dashboards, lookup tables, or selecting files for follow-up actions. Let's run this and see what's already in the system. The following snippet of code helps us retrieve the document ID for a target file. In our case, the uploaded mysalesreport.txt file, for demonstrating how we can update keywords of the file in the later parts of this notebook. Now let's talk about how to update keywords for an uploaded file using the update artifact keywords function. This function lets you modify the metadata tied to a specific artifact. Updating keywords helps keep your content organized and searchable as its context evolves. To use it, you need two things: the artifact ID, which uniquely identifies the file in the system, a new list of keywords you want to associate with it. Here's a typical usage. This replaces the current keywords on that file with documentation. It's useful when tags need to reflect updated context, like when content is reclassified or reused in a different workflow. A few tips while using this. Always make sure the artifact ID exists and is valid. The function doesn't return anything, it just updates the metadata. You'll need the proper permissions to make changes. Updating keywords is a quick way to improve content discovery without re-uploading or editing the files themselves. Let's go ahead and try updating an artifact now. In this line of code, we have used the target ID that we have retrieved previously. Now, originally, the keyword attached to the file, mysalesreport.txt, is sales. Now let's run the code and see if it changes to include the new keyword. As we can see, the keywords have been updated from sales to include the new sales keyword. SDK facilitates an API search to perform content search from the uploaded artifacts. Now we're getting into one of the most powerful features of the SDK, the search function. This function allows us to run semantic searches over the uploaded artifacts using natural language. And what makes it even more interesting is it doesn't just return matching results. It also suggests follow-up questions to guide users deeper into the topic. Here's how it works. The function takes a single argument, a search string, which is your actual query. It should be a well-formed descriptive string. What you get back is a tuple. The first item is the raw search result, usually a formatted content match like a paragraph, snippet, or document summary. The second is a list of recommended questions. These are automatically generated based on your input, helping users refine or expand their exploration. Here's how you might print it. This is extremely useful when you're building tools like intelligent document search, customer support assistance, or knowledge base explorers. The system doesn't just respond, it helps you ask better questions. A few best practices. Make sure the content you're searching is already uploaded and indexed, otherwise you'll get empty results. Craft clear search strings. The more specific your query, the more relevant the output. You can even loop through recommended questions and call search on them too, creating a chain of insights. Let's go ahead and try searching something meaningful. Here, we have used the recommended questions and got the answers for those questions, using semantic search over the uploaded artifacts. Next up, let's explore the Get Recommendations function. This is what powers SelfNeuron's personalization layer. When you call this function, it returns a list of content suggestions based on user interactions and previously uploaded or searched artifacts. It's an adaptive system that gets smarter as you use it. Here's a basic example. Each recommendation could include a document title, a keyword, or a phrase that the system believes is worth exploring further, based on what's been uploaded, searched, or interacted with in the current session. This is especially helpful in content discovery scenarios, or when building features like suggested next reads, autocomplete topics, or follow-up actions for research assistance. Two quick things to keep in mind. The more context you give the system via searches or uploads, the better these recommendations get. And results may vary depending on your data set and how recent or relevant the interactions are. Let's run it now and see what kind of recommendations the system has lined up based on our session so far. Next, let's take a look at how to update user profile information using Update User Profile. This function lets you change the user's name and update their agreement to terms and conditions, all in one call. It's useful for onboarding flows or profile management interfaces where user preferences may change over time. You can pass two parameters: username, the new name you want to assign. This is optional. If you leave it out, the existing name stays unchanged. Agreed's a Boolean flag to indicate whether the user has accepted the latest terms. It defaults to true. Here's what it looks like in code. A couple of things to note. This function doesn't return any value, but it updates the profile data on the back end. Let's try running it to simulate a profile update after terms acceptance. Now let's pull the current user's profile details using getUserProfile. This function gives you access to personal data tied to the authenticated user, like their username, email, address, or any other stored preferences. It's great for displaying profile info, personalizing the UI, or verifying account ownership. It's super straightforward to use. Or to make it a bit more readable, the return value is a dictionary, so you can easily loop through the keys and values or plug them into your app's front end. Quick reminder, the function requires no input. It works based on the current session. It's a clean way to build user account pages or conditionally render UI based on who's logged in. Let's run it and take a look at the profile data we have access to. Now let's look at the Generate OTP function. This is a developer utility designed to trigger a one-time password, or OTP, for a specific email address. It's typically used as part of a secure authentication flow, like verifying a user's identity before login or confirming access to sensitive actions. The function is simple and takes just one parameter. That line sends a secure OTP to the provided email. It doesn't return anything, it just performs the send operation behind the scenes. Some key use cases include two-factor authentication passwordless login, secure user validation for account management tasks. A few important notes. The email must be valid and accessible. This is where the OTP will land. If there's a problem with the email address or delivery, your app should be ready to handle the error or retry. Let's go over the getUserBilling function. This function retrieves a list of billing records associated with the user's account. Each record contains key details about subscriptions, billing cycles, and payment status. Everything you'd need to build a transparent, user-facing billing dashboard. Depending on the plan, you might also see fields like renews on or billing address, though those may not always be populated, for example, in the case of free or inactive plans. Here's a quick usage snippet. This is especially helpful for giving users visibility into their active subscriptions and past billing activity, or powering admin panels with invoice-level detail. This is exactly what you'd show in a billing dashboard: clearly labeled plan details, cycle info, and subscription status. Even if the subscription is free, this kind of visibility builds trust and supports billing logic in your app. Before calling it, make sure the user is authenticated and be prepared to handle cases where no billing data is returned. For example, if the user is on a free plan, let's run it and see what billing info we've got available. Let's take a look at getUserMetrics, a key function for tracking how much of the system a user is consuming. This function returns a detailed breakdown of usage and limits across multiple timeframes. It's great for monitoring activity, enforcing fair usage, and surfacing quota-related insights in your UI. The output is a dictionary, and here's how you use it. The keys in this dictionary include usage stats like daily queries used, monthly file size, and yearly quarter used, limits such as weekly query _life and monthly file size _myurge, meta info like product name and status. This is especially useful if you're building dashboards, metering systems, or alerts for usage limits. It supports daily, weekly, monthly, and yearly granularity for both queries and file sizes. A few notes. The user must be authenticated. This function is scoped to the active session. The return data might vary depending on how your application defines limits or allocates usage. Let's go ahead and run this so we can view the real-time usage metrics for our account. Here's the actual response from getUserMetrics, and let's quickly walk through what we're seeing. At the top, product name is currently none, which likely means the user isn't tied to a named plan. Usage-wise, the user has made 3 queries: daily, weekly, monthly, and even yearly, all aligned so far. You'll notice the query limits are clearly defined: 25 per day, 175 per week. Monthly and yearly limits are set to 0. This might mean they're not enforced for this user or haven't been configured yet. Looking at file size, the user has uploaded about 0.0006 MB in the past week, month, and year, so very light usage. Lastly, the status field is none, could mean inactive or undefined status, depending on how the backend handles that value. This kind of breakdown is super helpful for tracking usage trends, debugging access limits, or surfacing quotas inside a user dashboard. Let's continue. Let's wrap up the subscription side of things with Get Active Subscriptions. This function gives you a list of all active subscriptions tied to the current user account. It's ideal for billing portals, account dashboards, or anywhere users need to view or manage their plans. Here's what it returns: a list of dictionaries. Each dictionary holds details like subscription ID, the unique ID of the subscription, billing cycle, like monthly or yearly. To use it, it's as simple as this. This function helps with both subscription transparency and back-end logic. You can show users what they're currently subscribed to or make programmatic decisions based on plan type or billing cycle. Let's call it and check what active plans are associated with this session. Let's look at how to retrieve search activity using the Get Search History by Date function. This call fetches search history from a specific date and optionally filters it by user ID. It's great for analyzing patterns, generating usage reports, or debugging user flows. Here's a basic example. The result is a list of dictionaries where each dictionary contains search term, what was searched timestamp, when the search happened, user ID, who performed it, results count, how many matches were returned. This is especially useful for tracking what users are searching on any given day. Great for product analytics, support teams, or behavior modeling. A couple best practices. Make sure the date string is in the correct format. If you want all users' data for that day, just omit the user ID. If you want to drill into a single user's behavior, pass in their ID as a second argument. And remember, it may return an empty list if there was no activity on that date. Let's go ahead and try pulling search history for a recent date and see what comes back. Now let's take a look at Delete Search History, a function that permanently clears all stored search activity for the current user. This is a privacy-focused utility. It's especially useful in apps that handle sensitive data or need to stay compliant with data protection policies like GDPR. The call is simple. It doesn't return anything. It just performs the deletion behind the scenes. A few important things to keep in mind. This operation is irreversible. Once the search history is deleted, it cannot be recovered. Make sure the user has the appropriate permissions before allowing this action in your app. It's also great for reducing storage overhead if your system logs a high volume of queries. Because this affects stored data, be cautious about when and where you run it, especially in shared or production environments. We can see in the SelfNeuron.ai dashboard that there are 3 search records under the Search History tab. Let us now run the function. As we can see, the function call has deleted the search history in the authenticated account. Let's move on to the next function. The last function in this video is the delete account, a function designed to remove a user account and all of its associated data from the system. You can use it in 2 ways. Provide an email to delete a specific user's account, or leave the email blank to delete the currently authenticated account. Either way, the function doesn't return anything. It silently performs the deletion. This is ideal for systems that support self-service account management, whether for privacy, data cleanup, or regulatory compliance. Some important points. This operation is permanent. Once deleted, the account and all its data are gone for good. Make sure proper authentication and permission checks are in place before calling this in production. Whether it's a user closing their account or an admin clearing inactive ones, this function gives you full control over account lifecycle management. We're not running this live for obvious reasons, but it's a critical capability in any user-driven platform.